Hi, I'm Param Singh. Hope you guys are doing well. In the last video, we learned how structs can be used to model data that naturally belong together. And we can also name the fields of that data. So in this problem, we are going to design a data called movie, which has a title, a budget, and release year. So this is the key part of this problem, to design data abstraction using structs. And once we have designed it, we'll use it to illustrate how we can create functions that consumes the data abstraction that we have designed. We're going to represent this movie with a struct with three fields: a title, a budget, and release year. Once we do that, then we are going to use that to design the following function. A function that consumes two movies and produces the title of the most recently released movie. I want you to focus more on the first part because that contains the most new information that we have not seen before. The nature of the design recipe does not change, so we are going to use the same steps: writing the spec, purpose statement, stub, tests, and implementation and testing. So with that said, let's jump onto our editor and start some coding. So here we are. We have a blank slate, a def module called movie, and we are going to use this module to design our movie data abstraction. So let's start the first thing with the module doc. So just like a doc represents the purpose of a function, a module doc represents the purpose of the module itself. Since we are using the module here to design a data abstraction, we have to note here that what does a movie represent? What kind of information does it represent? So we say represent a movie with a title, budget, and release year. Of course, we can be a little bit more specific with the budget, and we're going to say we'll work with US dollars. So this simple information provides useful context. Second step is to define our struct that represents that movie. So we start with def struct, and it has a title. There is no default value for a title, neither a default value for a budget, and nor for a release. So there we have it. In the second step, we have defined our struct, and note that the name of the struct will be derived from the name of the module. So that's why we don't have a name of this struct. All we are saying is it has three fields: title, budget, and release, and all three are set to nil. The third part of our data abstraction design is going to tell what are the types of these fields, right? So we are going to create a new type, and we will name this type as T. We'll say %, and then we are going to use a special word here called module. Return the module name of the current module, which is the movie. We start curly braces, and title, we're going to say it's a string. Budget, we will say it is a positive integer, and similarly release will also be a positive integer. And the last thing is to define a function, all right, called new, that takes these three values, takes a string, takes a positive integer and another positive integer, and it produces a movie. So this is how we can refer to the type of the movie. Name of the module, which is movie dot t, because t is a type we have defined here. We can just say produces a new movie. All right, and then def new, right, and we can say title, budget, and release, and do, and we're going to produce this struct. So we'll set the title to title, budget to this budget, and then release to the release. So this function essentially simplifies the construction of a movie instance, if you will. So there we have it, a data abstraction for the movie, where we have a module doc telling what movie is about, def struct telling how the movie can be constructed, what are the types of the fields for that struct, and a function to define the movie. Let's go on to designing the function that consumes two movies and produces the title of the most recently released movie. So we start with spec and we say recent title. All right, and it's gonna take a movie type and another movie type, and it's gonna produce a value of string because we're gonna produce the title of the movie. So we write our purpose, produces the title of recent most recent of the given two movies. And the next thing is the stub. So the stub will be, we're gonna say recent title, and I'm just gonna give it two variables and produce a value of type string, and that's our stub. Going to the test file, we are not going to write the test since we have written already because they are kind of verbose. The new thing here is the describe block, and describe block allows you to group like tests together. The first test is to return the name of the first movie when it is recent. So we create two movies, Inception and Matrix. Inception is more recent, so we produce the string Inception. In the second case, the Social Network is most recent, so we produce that. In the third case, both movies, Social Network and Inception, were released in the same year, so we produce the first one of these, and that's why we produce the Social Network here. So with this information at hand, let's see how do we design our function. So what we are gonna do is create a do block. The first thing we want to do is extract the fields that we are interested in, and that we can do with the pattern matching. So remember, the pattern matching for a struct starts with %, name of the module, and the two fields we are interested in is title, right? title 1 and release 1. So this equals to movie 1. Similarly, we do a second match, title 2 and release 2. Now all we have to do is make a comparison of the release year. So we say if release 1 is greater than equal to release 2, right, then produce the first title, else produce the second title. And let's see how this design fares with our testing. So we say mix test, and all 3 tests pass. The fact that we were able to pattern match to extract the fields is probably the most important part in this function design. Other than that, the key piece here is the design of the data, which is the movie here, which once again, to recap, we are doing by specifying the module doc, defining the movie with def struct, defining the type with type t, creating a function to create a new movie, and using the movie.t in these functions. So I hope this is useful, because this forms the foundational knowledge for creating any kind of data abstraction that you would like for your problem sets.